protons in the ortho position, so you can get two different benzynes, and each of those benzynes gives us different products. So the total number of products is 3. Does that sound okay with everybody? Yeah? Cool. Now draw it out, finish the whole thing. I didn't mean to stop you from what you were doing. Plus the other one too, right? Because this one is going to give us 2.
This one, yeah. Oh, yeah.
So just draw.
Sorry, I just thought because it was there.
No, right.
I'm
We
sorry.
don't want to convey in any way that you only get 1 there, but 2 there.
What was the point that you said this last
Because
thing?
we get 2 different benzynes. See, the difference between the 2 examples here, there was only 1 ortho hydrogen. You could only get 1 benzyne. But here, in this case, there are 2 hydrogens on ortho positions. So if the base takes this one, you get that benzyne, and you get the 2 products. But if the base takes this proton, you get a different benzyne. They are different from each other, which gives it salt. So that's why we have a total of 3 products.
Thank you.
Guys, is that okay? So these are the different substitution reactions of benzenes. Just to compare the 3 substitution reactions, aromatic substitution reactions. I'm only talking about the substitution reactions. If there is some group on the benzene, if we react with an electrophile, one of the hydrogens is substituted by the electrophile. Isn't that right? And of course, you'll either get ortho, para, meta, depending on what the G is. Is it an ortho, para, director, meta, director, blah, blah, blah. That is electrophilic aromatic substitution. And what's the intermediate in an electrophilic aromatic substitution? What intermediate does that mechanism go through? Sigma complex.
Sigma complex, okay.
Which is a plus or minus? Is it a positive charge, minus, negative?
Cation.
It's a positive charge. We wrote that, right? Bromination, halogenation, nitration, sulfonation, alkylation, acylation, all of those fall in that category. The important thing to keep in mind is, or notice is, a hydrogen is being substituted, not the group. The group stays where it is. Or a nucleophile can come in and substitute the group, not the hydrogens this time. It's whatever the group is being substituted. Maybe I should write that, plus H plus. That's a nucleophilic substitution. But which mechanism will it go through? Well, it will go, if strong electron withdrawing group in ortho/para position to the leaving group, then we do the addition followed by elimination mechanism.
Carb anion.
In both, yeah. On the other hand, if no electron withdrawing group, then the mechanism is the benzyne, its mechanism. So there are 2 options for the nucleophilic substitution process. So based upon what you're using, you can decide, okay, this should happen or that should happen. Does that make sense, everybody?
Yes.
Everyone okay? Could you take one at a time? Okay, so this is benzene. Let's go ahead and summarize all that we know about benzenes. Reactions, I mean. Oh, I need one. Thank you. Now, what I'm handing out right now, actually, we've only done part of it, about half of it. The rest of it will come a few chapters later. So you might want to save it, actually not even a few chapters later, probably the end of the quarter is when we do the other half. We look at amines. But, so you might want to save it. But at least let's work through, let's fill in the part that we do know about, which is the first half, the left half of the page, and summarize it all. So starting with benzene. How do we convert it into halobenzene? And halogen meaning either chlorine or bromine.
Fe or,
X2 and
With a
acid.
Lewis
Oh, yeah.
acid.
mhm.
Either it's FeBr3 if you're
Yeah.
using bromine or AlCl3 if you're using that. Okay, and how do you convert that into Grignard?
Magnesium.
And then all the wonderful things we can do with the Grignard, as we already know. Right? Cool. How do we convert it into benzene sulfonic acid?
Fumed sulfuric acid.
Or you can say sulfuric acid with sulfur trioxide gas.
Yeah.
Either way is fine. And how do we go in the reverse direction?
Dilute sulfuric acid.
Everybody okay? Convert this into alkyl benzene. How do I convert this into alkyl benzene?
Friedel-Crafts alkylation.
So what do we use for that?
RX Lewis acid catalyst.
Exactly. Either alkyl chloride, alkyl bromide with the appropriate Lewis acid catalyst, FeBr3 or AlCl3, depending on whether you're using Cl or Br. Same thing, mechanism we did. Agreed?
Mhm.
How do we do Friedel-Crafts acylation? What do we use?
Um,
An acid,
Not a,
not acid.
oh, did you say acid? Like what kind?
Oh,